Alright, we're going to draw a damn, oh, what the hell are we drawing today? My memory. We're going to draw a fixture plate. So we're going to pick the front plane, click the little drop down, normal to. And we're already in our crosshair. So we'll do like I like to start all my drawings, hover out there. So I learned this from my first teacher, and I'll just keep doing it. Works for him, works for me. Hover to see relation, click, double click to release it. Hover to see relation, click, drag it down. See the relations again, click, hit escape. Now we're going to draw a rectangle. On this one we're going to use from center to outside corner. So we'll pick the center of that box, and then we just drag it out until we're comfortable with it. I'm stopping right before it gets to the ends of those crosshairs just to make sure that it don't lock onto it. Smart dimension it, tell it how big we want it to be. So we'll make it 10 inches in the Y, and then we're going to make it 12 inches in the X. Click the feature button, click extrude boss or base. We're going to extrude it 2 inches, so we just type in the 2 inches that we want. Click our check mark. Good to go. Click the face that we want to work on, click the normal to, drag it up there. Go in the hole wizard. We're going to pick counter bore. Since we're putting in socket head cap screw, we're going to make sure that our socket head cap screw is lit up as our selection. You know, it gives us all these different options. Metric, different types of metric, different fits, all that. So we're on this one, we're doing a 1/2 inch, so we're going to use 1/2 inch feature. Normal fit. You know, we could do some old NASA fits, we could do some old sloppy fits, but we're just going to do old normal fit. Right, run of the mill. Pick our plane, which I accidentally double click and put my hole there, but it'll move when we put our dimensions to it. So we'll dimension from top line to center, and that'll automatically drag it up there. And there we go. Try that, see if it works. Not enough, so we'll redimension that. Get a little bit better to our liking, rather. We'll do the same thing, dimension from the center of the circle to the edge. Tell it how far we want it over that one. You know, how far in the X. Click our check mark. Go back to features. A pattern, or if we could have just clicked the mirror button. We're going to pattern this single feature. Of course, we you know, once that one's done, again we need to pick the line that we want it, or what we want to mirror about, when it already picks the feature since we were just working on them. So it all automatically knew to mirror that, whether in the X or the Y, depending on what plane we're mirroring about, which is why we draw from the was drawn from the center of the thing. Now here we're just picking 1/2 inch 13 tapped holes all the way through the plate. So we'll throw one up there, then we'll go to Smart Dimension. Do a little dimensioning. Now considering this plate is 10 by 12, it's even, so we need to try and stick the things that are going to round evenly into that as far as our dimensioning. That way when we do spread it across there, it's going to be a lot easier to fit them on the plate. You know, if you were making them some oddball size, 257, that 7 is going to compound across that plate. When you get to the other side, you're not going to have any way to match it up outside of pure luck or such a small tolerance variation that you just don't notice it. Okay, so here we're just doing a dry run. We're going to have to do some math to make sure we're right, but we think that we're pretty close. So we're going to close out of that and open up the old calculator, do the math to make sure that it's we're coming up with the right number, and then we will throw it back out there again. So we're going to measure from hole to hole, measure from the center of the hole to the center of the hole. So it's telling us how big it is between those two holes. We know that we just had 13 holes up there. You always add that extra space in, so you're going to put in 14. So now we know that our 0.75 is what we want to fit those holes between those other two holes evenly. So again, we'll pick that top edge, tell it that we want it to go, and you can see the arrow up there on the right hand side, top of the stock. So we're going to put in this 0.75 space in between the holes. Then we're going to tell it how many holes we actually want. And there you go. 13 evenly spaced holes. So now we're going to do that same, we're going to array these in a different direction. Pouring me some more coffee. So we're arraying them in a different direction. So again, we're going to have to do math and figure out what we got going on here. And there we go. Crikey, she's a beaut. So now we'll have to, I don't know how to fill in that other little side space without doing an extra step, so which isn't a problem. So we'll just go back into our hole wizard, pick the same thing that we already had. Here we're going to go in and create a sketch, just a construction line, I reckon you'd say, and just drag it out. That way we know it's center to a hole that's already in the plate. Then we're going to add relations from the hole we just drew, or the hole we're trying to plug in, to that line, and you'll see to automatically drag that hole center of that line. And there we go. Now all we have to do is add our relations in the X, or our spacing between the two holes, and that should put that one in, you know, the same arrangement as the rest of them. And then we'll do another linear pattern and lay those suckers out, you know, down the y-axis, and then we'll do a mirror across the x-axis and just pop all those holes we just put in on the other. So essentially we're only drawing two holes on this whole plate. So we can change those 2 holes and all the other holes are going to update. So there we go. Now we'll just tell it how many that we're going to put in there. So we're going to put as many of them as going to fit in there. It's going to leave us a little bit of dead space, but again, we're just making this stuff up as we go, so we could fine-tune things and adjust things to squeeze as much in as we could. Now we're just going to do the mirror. We're going to pick the plane we're going to mirror about. It automatically knows that we're working with those holes we were just working with, so it puts it there. So now you've basically got an entire plate done. So now we're going to go in here and draw the recesses that you could put the toe clamps in. Because again, only 2 of those counterboards are going to line up at any given time to your T-slots on the table, unless you're just lucky. So we'll just draw basically a rectangle. This time we're using corner to corner instead of center to corner. Either one wouldn't have mattered. Center to corner might actually have been easier, because we wouldn't have had to draw this construction line that we're drawing in order to relation it to make sure it's coincidental, I guess you would say. Which basically you just pick, shift click, pick center line, shift click, pick the outer line, and add the coincident relation, and it'll automatically center it. That way any dimensioning that you do, it's going to dimension it and keep it centered. So then we add our up and down dimension, 3/4 of an inch, 9-inch length, and now we're going to dimension from top to bottom, and that's going to lock that, I guess you could say, the height that it starts at, that the slot starts, which we left a 1/2 inch of meat down there. So we're going to make that, we'll pop that in there. Now in this case we can't go as deep as we want because the holes are 1/2 inch centered off the edge, 250 thousandths on either side of that center, which only leaves us 250 thousandths to work with. So on this next, and then we just mirrored it. All we did was pick the plane, since it knew what extrude we were just working with, it mirrored it across that plane. So now on this side we'll be able to go a little bit deeper, because we don't have, we're not exactly, I think we're 3/4 of an inch off the sidewall, something along those lines. At any rate, basically the same principle. We're going to draw a freaking square. We throw in a construction line to relation it about. We'll go ahead and add our relation. Click, shift click, click, shift click, or shift click, excuse me. Add the coincident relation. Then we'll add our dimensions. 3/4 of an inch tall, 1/2 inch off the bottom. And since we're just doing this by eye, sometimes I'll wait until I click a line and see how long it is, and then make a determination on how long I want to try and round it wherever it needs to be rounded. You know, if there's other dimensions that we need to stick with, like that, the 1/4 inch or the 1/2 inch and the 3/4 of an inch dimensions we have to stick with. But this side to side dimension, well, we can really get willy-nilly. So my biggest determining factor is, where are those counter bores located on the ends? And that's the only thing I really need to avoid. So here we're going to go ahead and mirror it. Now that we've put our extrusion in, We went 400 thousandths deep, I believe. Now we're going to mirror it, so we'll pick the plane we're going to mirror about. It already knows what we're trying to mirror because we just drew it and extruded it. So it automatically throws it across there. And there you go. Simple, simple, simple. So now we're going to go ahead and put in our we're going to chamfer all of these holes. So basically we just go into our chamfer, we pick our very first chamfer that we drew, then we just pick our two mirrors, then we just pick the first hole we drew, then we pick the all the mirrors or the linear patterns that came off